Good afternoon, everyone. My name is Daryl Lester,
My name is Keith Mclntosh.
and this is our midterm presentation for our Engineering 305 class. The objective that we were given is to create a single-cylinder oscillating steam engine with the use of CATIA, as shown on the screen. The final assembly was broken into 4 sub-assemblies consisting of the frame, flywheel, piston, and cylinder assembly. The first assembly was consist of the frame. The purpose of this object was to hold up the entire engine and to allow a rotation point for the flywheel and a pivot point for the piston. As you can see, there's 2 circular tubes at the top and right side of the object. These allow the steam to enter and exit the engine. And the holes in the center and the top hold the piston and the flywheel. As seen in the next page is an exploded view of the frame assembly. Each part was designed separately in CATIA and assembled in a final assembly. The next assembly consisted of the flywheel. The purpose of this object was to convert linear motion of the piston to rotational motion of the flywheel. This object was supported by the frame, where it rotates about the bottom hole. In the next slide, you will see a exploded view of the flywheel assembly, where it consists of the flywheel and the rotating shaft.
And here we see the third assembly, the piston assembly, which consisted of a piston head, a rod, and a crankshaft bearing. Here in the exploded view, we see the different parts of the assembly, with the piston head and its nylon seal, creating a solid wall between the 2 sides of the cylinder that it would creating a difference in pressure that moves the piston up and down the cylinder, with the motion being carried by the rod down onto the crankshaft by the crankshaft bearing. And in the fourth and final assembly, we see the piston itself. As you can see, the piston is a contained pressure vessel with a hole at the bottom to allow for the piston to enter, and 2 holes on the back cover plate to allow for the inlet and outlet of steam coming from the 4 holes as seen on the frame. The whole assembly sits on a rocking shaft, which sits on the frame and is connected on the other side. The whole assembly is made of a bronze material, with the fasteners and shaft being made of steel. Here we can see each individual part, where you can better see the rotating point where the piston would sit on the rocking shaft, and the 2 holes that let the steam enter and exit. And now here we see one problem we had with this project, with the documents we were given, was that this bracket did not have a dimension for its width. Initially, we assumed a width of 4 millimeters thick for these brackets as to scale with the images given. However, when the fasteners were added later in the project cycle, it was found that the length of the fasteners given did not fully reach the end of the second bracket. We then updated the bracket width so that the fasteners would fit properly. And finally, we have here the final product. We can see here altogether, after going through all of the individual pieces, we have the inlet for the steam that goes through the guided holes in the frame, traveling through into the piston cylinder, which would then move the piston up and down along the crankshaft, oscillating the cylinder to the left and the right as it moves around its cycle. As this motion is happening, the energy and momentum of the motion is captured in the flywheel to be used in whatever purposes this steam engine would be used.